Hello, today we are going to discuss about the different data types which are available in Java. Basically, in Java, whenever we are trying to store some value, so that value, for storing some value, generally we use this type of statement. So, this is what? This is the data type. If I have a value like 20, so this type of value are called integer. If I write 20.3, these are called floating point value, and as per the requirement of the data, if the data size is, say for example, 2930, a long value, 5 digit value, 10 digit value. So, whatever the value is, corresponding some data type is available. Now, this is int in stands for integer. It can able to store the integer value, and x is the variable name. So, in our memory, some memory space will be allocated, and in that memory, if we write x equal 20 and 20 value will be stored. Now, whenever we are trying to store some character value, so the character is also can be stored. In Java, there are different data types which are available, like these are the data types with different data types. What are these data types? In Java, there these data types are like, this is classified into two different types. One is called primitive data type, and another data types are called non-primitive data types. These data types, primitive data types, are also classified into two categories. One is Boolean. Boolean means in true and false. In C language, we do not have this Boolean data type, but in case of object oriented programming, there we have this true and false. So, here this Boolean can have two type of data, one is true, another one is false, FALC. So, these are the different values. Then there is numeric data. Numeric can be character, numeric can be integral. Integer can be divided into two categories, one is integer, another one is floating. Now, these integers are can be byte, can be short, can be int, can be long. Floating point can be float and double as per their size of the data. And primitive data types like string, array, and other data types are also available. So, if we have the different data types, like these are the data types which are the primitive data type, they have some specific size and corresponding they have some specific default initial value. Let us have a look their default initial value and their what data they are holding or what is the size. So, these are the different data types that are available, and if we try to know their size of this data, then let us have a look. These are the, say for example, in case of if I try to define the size of byte, in this is I am representing in the form of bit. Byte is of 8 bit, short is of 16 bit, integer is of 32 bit, long is of 64 bit, floating point it is of 32 bit, double it is of 64 bit, character it is of 16 bit, Boolean it is of 1 bit. That means, whenever I am trying to allocate some memory space, say for example, I am writing int x, this x will occupy inside memory what data type size is there. So, it will occupy 32 bit. Okay. If I am going to store character, if I am going to store character like CHARP, P is the character value. Now, P will occupy how much space? It will occupy 16 bit. So, definitely the size of according to the different data, what is the size of the data according to the data type we will select. Okay. So, it will occupy less space, this will occupy higher place, and they have their default values also, default initial values. So, byte is of, these are the default values, So, this byte is of 0, short is of 0, int is of 0, long is, it can be sometime it is written 0, sometime it is written long L, 0 L. Floating point like 0.0 f, and this f must be mentioned. Double, sometime it is 0.0, or sometime we can write d also. Okay, d also, or if you do not write this will by default it will understand as the default value. Character has a special value, that is value is /u0000. So, this is the value it is holding. Then comes Boolean. Boolean can have only two different values. One value is called true, it can be true, and another one is false. By this we generally check the condition, wherever some condition is required to need to be checked, then by help of this value we initialize these values. By default the Boolean, the value of this one is false. These are the default values. Now, if I write some code, if I try to write some code like we are having some value like so if we are trying to having this particular place. Now, what I am trying to do, I am say for example, I am declaring two different data types. Say for example, there are two variables like byte, I am declaring byte byte x. So, x is a variable which is of byte type. So, x will occupy how much space? It will be 8 bit. So, if I declare integer y, then what will happen? So, y will occupy how much space? It is of 32 bit. It is of 32 bit. Okay, it is of 32 bit. So, definitely the size of int is higher. Now the interesting part here. Now, if I have stored inside y as 10 and inside x if I have stored 9, or I have also stored 9 here. Okay, I have also stored whatever value. Say for example, I don't want to store. I have stored 10 here. I have stored y. Okay, just I am changing this value. Okay, just have a look. I am just assigning this x as 10. Now, what I am trying to do? I have stored here 10. So, x is occupied with stored with 10 value. Now, what we are trying to do? We are trying to store y equal x. Then what will happen? You will say yes, this y will be 10. That is correct. Yes, it is correct. But if we try to, rather than doing this, if we try to this particular job, I am not assigning x as 10. I am not assigning x as 10. I am assigning y as 10. I am not assigning this value, by default value is 0. I am assigning y as 10, and now I am trying to write, I am not writing this line, I am writing x equal y. Then what will happen? Y is having 10, but its size is higher. So, the value will be accommodated in that particular size, and if we try to store it here, if we write x equal y, we are trying to store this value, then what will happen? It will not store, and this will arise compilation error. But you will say, how is it possible? In the previous case, when I am trying to store this value from here to here, I am trying to store some value from here to here. So, as the size is lower size data can accommodate in the higher size, and that is called auto casting. The system, the compiler will automatically cast the value, change the value into its higher type. Now, but higher value cannot be accommodated. Let us have a fun example here. Like if we think about, there are two different animals, one is giraffe, another one is rabbit. They are trying to accommodate in a bucket. Now, this giraffe is of a large element, definitely. If we try to accommodate, this giraffe is trying to get place inside this particular bucket. Is it possible? Definitely not. If I say this rabbit is possible, if this rabbit is trying to accommodate in this bucket, yes, it is possible. So, in our language, in our Java language, we have different size of buckets. Sometime it is small, sometime it is large, someone is large, someone is small. So, whenever we are trying to store, they have different size, they have their different size. So, whenever we are trying to store some value, whenever we are trying to store some value from higher to lower, we have to always take care about the different scenarios. What are these scenarios? If I try to store the higher value, lower value in its higher size, it is okay. But if I try to store the higher value, this value inside this will arise compilation error, this is wrong. If I try to store this value here, this is wrong. If I try to store this value here, this is okay. So, we have to remember this scenario. We have the scenario about the giraffe and the rabbit. Rabbit can accommodate in giraffe's home. Wherever giraffe lives, he can accommodate. But if giraffe is trying to accommodate in the bucket where the rabbit lives, that is not possible. So, how would we will make it possible? By help of some mechanism. That mechanism is called type casting. So, from this to this is not possible. By default, it will arise compilation error. But this is called, but whenever we are trying to, this rabbit is trying to accommodate here, because this is higher, it is lower of size, it can able to accommodate. So, this is called automatically, this is happened, this is called auto casting. Auto casting, and whenever we need to forcefully, we have to convert the higher size of data into its lower size, then it is called type casting. So, we have to remember, we must remember the examples, this particular table we have to remember. Byte, it is of 8 bit, short 16 bit, integer this table, yes, this one. A byte 8 bit, short 16 bit, integer 32 bit, then long 64, float it is 32, double 64, char 16, and boolean is 1. We have to always remember this particular table. We have to remember this table whenever we are writing any code, any working with some data, always we have to remember this table. If we try to accommodate the higher size of value in the lower size, then there will be a problem. We have to go for the casting. What is casting actually? When we are trying to convert the type of the data into another type, that is called casting. When the compiler automatically converts, that is called auto casting, and whenever we are trying to force the programmer writing some code to cast it, then it is called type casting. Let us have a look about these examples. So, here in this example, look here int, what is the size of int? What is the size of it? Int is of 32 bit and byte is of 8 bit. So, integer is of 32 bit and this is of 8 bit. So, I am trying to store a value which is of lower into higher, it will be correct, no compilation error will be there. Now, pause the video, think about this example. So, I have a byte which is of 8 bit and this is of 32 bit. So, what we are trying to do? 32 bit we are trying to store in 8 bit location. This is not about the value, the format, how the value is already arranged. When we store 20 inside I, then it will be arranged, it will be just accommodate the total size. So, the format of the value will be changed. Then this one will arise compilation error. This will arise compilation error. To make it correct, what we need to do? We have to convert. If we write here b equal byte 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 I, if we convert this value, then we can able to convert the value. Okay. In this case, think about this example. So, in this case, look, byte is of 8 bit, boolean it is of 1 bit. Now, I am trying to store B inside A, or whatever I want to store this one. What will be this case? Pause the video and think about the case. Okay. In the both cases, so in this case, A B is trying to accommodate inside A. So, this will also arise compilation error, and this will also always arise compilation error. Why? Because always remember, Boolean value never be typecasted into another type. Whether this is Boolean to another or another to Boolean, it is not possible, it is always arise compilation error. Then another example. So, here it is character, it is of 16 bit, it is of character, it is of 16 bit. Have a look, character, it is of 16 bit. Now, what will happen? This is 16 bit, and integer, it is of 32 bit. So, what we are trying to do? This character inside this, so it will okay, and it will say, so 65, it will, the value will be converted into its corresponding type, and it will be, so it will show its ASCII value. But in this case, Z is a character, and we are trying to store integer value here, this will arise compilation error, we need to typecast. In this case, float, in case of floating point type, if we write this one 9.5, it is float, we have to write in this way, int I, and if float is there, we want to store in inside int, then always we have to typecast it, otherwise this will be an error. And in this case, this is another example where byte B1, byte B2, we are adding them and storing inside byte. What will the output? You will say it will work, but no, it will arise compilation error. It will arise compilation error, because the operation between 2 bytes always it converted into corresponding INT. So, this will arise compilation error. Another hint, that is, whenever we are performing any operation between long and double, the value is converted into double. So, if we try to store inside a long, then there will be some error. So, this value operation between them, it will always arise some error. Floating point value, this is another concept. Float f 3.0, if we write this, compiler think this as a double. As we are trying to store double here, it will arise compilation error. So, if we try to make, there are two things, two way to solution, that if we have to convert, typecast this, or f equal to float f float, float f equal 3.0 f, or double 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 k, any variable 3.0, this will be correct. Okay. So, this way we can represent our variables, we can use our variables, and this way we can remember how to convert the values, how to typecast the values. Thank you for today. If you have any queries, please go to the comment section and definitely try to reply.